Welcome back. Okay, let's just cut right through the hype today because in this explainer, we are completely demystifying artificial intelligence. We're taking AI out of the realm of sci-fi and breaking down exactly how it works under the hood. By the end of our time together, you'll have a crystal clear understanding of the structural frameworks powering the technology that's, well, literally shaping our future. Okay, let's dive into this. To really grasp where we're going, we kind of have to look back. And it all begins with one fundamental question. Can machines think? That was posed by the brilliant mathematician Alan Turing in his famous 1950 paper on computing machinery. Turing proposed what we now call the Turing test, a theoretical scenario where a human interrogator tries to distinguish between a computer's text response and a human's. That simple, yet totally profound question, it ignited an entire scientific revolution.
Here is our roadmap for today. We'll start by demystifying AI, then look at its nested layers. After that, we'll cover generative AI and agents, explore some real-world applications, and then finish up with risks, ethics, and governance.
Chapter 1. Demystifying Artificial Intelligence. So, Turing's question back in 1950 sparked a revolution. Fast forward just a bit to 1956, and John McCarthy officially coined the term artificial intelligence at a Dartmouth conference. Then, in 1997, IBM's Deep Blue crushed Garry Kasparov in chess, which really proved that machines could master complex, strategic, rules-based tasks. And today, in 2024, we've evolved to multimodal large language models. These systems seamlessly process text, audio, and visual data all at the exact same time, which requires compute power that just completely dwarfs those early mainframes by orders of magnitude.
So the crucial point here is establishing boundaries. Everything we use today, from algorithmic trading bots to the virtual assistant on your phone, that's all weak AI or narrow AI. It's meticulously designed to optimize specific parameters and specific tasks. Strong AI, or artificial general intelligence, a system capable of generalized human-level reasoning across literally any domain, well, that remains strictly theoretical for now.
Chapter 2. The nested layers of AI. Think of AI architecture like those Russian Matryoshka nesting dolls. The outermost, broadest doll is artificial intelligence itself. It's the overarching technology enabling machines to simulate problem-solving and act with autonomy without needing any human intervention. That is the big picture.
Pop that outer doll open, and inside, we find machine learning. Instead of hard-coding explicit rules, we train algorithms using massive data sets. Through techniques like supervised learning, the model autonomously discovers the statistical mappings between inputs and outputs. This allows it to make highly accurate predictions entirely on its own.
And then we get to the innermost doll, deep learning. This is the real powerhouse. Utilizing artificial neural networks with an input layer, an output layer, and hundreds of hidden layers in between, it essentially mimics the human brain's architecture. This incredible engine allows the system to process vast amounts of unstructured, unlabeled data, and it's what drives most of the advanced applications we interact with today. Chapter 3. Generative AI and Agents.
Generative AI represents a massive, massive leap forward. Instead of just analyzing data, these deep learning models actually create complex original content, be it long-form text, highly realistic images, or even audio. They draw from encoded representations of vast training sets to build something brand new yet structurally consistent. And this breakthrough, it's been largely unlocked by transformers, which is a highly efficient neural network architecture that is just exceptionally brilliant at handling sequence data.
So how exactly are they built? Well, it's basically a three-step engine. First up, training. This means processing terabytes of raw data to build a foundation model with billions of parameters. Second, tuning. Here we adapt the model for specific tasks using RLHF. Reinforcement learning with human feedback, that's where human users essentially grade the output so the model gets better over time. And finally, you have a continuous loop of generation, evaluation, and further tuning to just constantly refine that accuracy.
And this brilliantly illustrates the next major evolution in the space. Generative AI is fantastic at answering prompts based on patterns, right? But AI agents take it a huge step further. They execute autonomous, goal-driven workflows. So a generative AI can tell you the best time of year to visit Nepal. An AI agent, however, takes that information, opens a web browser, independently books your flight, reserves your hotel, and coordinates your entire itinerary entirely on its own. It's the leap from just answering questions to actually taking real action.
Chapter 4. AI in the real world.
The tangible benefits are honestly staggering. We're talking rapid automation of repetitive tasks, Hyper-fast data insights that enable real-time decision-making, drastically reduced error rates, 24/7 availability, and, crucially, the delegation of highly dangerous physical labor to machines. All of this frees humans up to focus on high-level creativity and strategy.
And we're seeing this applied literally everywhere. Customer service systems are utilizing natural language processing to resolve inquiries instantly. Deep learning algorithms in finance are spotting transaction fraud in milliseconds. In manufacturing, predictive maintenance algorithms are analyzing live sensor data to flag an equipment failure before a machine ever actually goes offline. It's a real game changer.
Chapter 5: Risks, Ethics, and Governance.
Of course, rapid technological adoption naturally requires strict guardrails. The technical and operational risks are very, very real. Threat actors can attempt model tampering or data poisoning, which fundamentally compromises the parameters that make the AI function in the first place. We also face the operational risk of model drift, where an AI's accuracy actually degrades as real-world data shifts away from its original training data. And naturally, robust protections are absolutely essential to prevent privacy violations during that massive data collection phase. Now, what's really interesting about this is that addressing these risks isn't just a coding problem. It demands multidisciplinary governance. Developers, ethicists, and policymakers have to align on core pillars. This means establishing explainability so humans can interpret algorithmic decisions, ensuring fairness to minimize bias, building robust security against malicious attacks, defining strict accountability for outcomes, and maintaining unyielding privacy and compliance standards. It's the whole shebang.
So we've journeyed all the way from Alan Turing's foundational theories back in 1950 right up to autonomous agents independently executing complex workflows today. We've peeled back the nested architecture of deep learning and explored the multidisciplinary governance required to deploy it all. I want to leave you with this provocative question as we wrap up this explainer. As this technology becomes increasingly inevitable, how will you ensure AI is integrated safely and responsibly in your own workflows? Something to think about. Thanks for joining me and keep learning.